in particular with our inheritance demo. But before we did that, I wanted to make sure that we're all on the same page as far as the Gantt chart goes. We're checking in on that. Hopefully you did a really good job with your design documents and gave us enough details that we could provide meaningful feedback. If that was not the case, then what you're going to want to do is get an early working version of your code done this week, or early this week, so that you can go into help hours and get some feedback from LAs, and they can take a look at your code instead of your design document and give you that feedback. But otherwise, what you should be doing for the next 3 days is that initial implementation. Giving you 2 days at the end here to make sure that you're taking care of any bugs, that you are polishing it up with documentation, style, whatever, right? Although that should be from the start, etc. Right, so it gives you plenty of time to debug and test as long as you've got a working copy available early in the week. If you're waiting to the last day to start on any of this stuff, it's not going to be good, okay? All right, so let's go back over here to our original demonstration. Remember that, I'll just make sure that everything is working. Yep, good. All right, so remember that we were going through this demonstration here where we're going to draft a collection of financial asset classes. We started with a savings account, and then we went to an annuity. A savings account has a chunk of money that you put into the bank. It pays you monthly interest on it, etc. An annuity is a product that you buy up front for a large amount of money, and then they pay you a fixed amount each month over a certain number of years, okay? Now, what we did was we started out by identifying what should be in each one of these classes. There's the savings account, there's the annuity, right? And I didn't go through the process on Friday, but I did just now, right before class, of generating all of the constructors, getters, and a to-string method so that we could actually play around with it, okay? So let's go ahead and go over here to demo. And now we can actually achieve what I wanted to do, at least to start out with. I want a savings account with $100 that pays 5% interest. So let's go ahead and give me a savings account. S is equal to new savings account. Right? And I forget what they are but at this point, but there's an account number, me, a balance, and an annual percentage rate here. So an account number, we'll just make something else, 1, 2, 3, 4, me, all right? We'll need to take care of that here in a second. And then I want $100 and 5% interest. Remember that 5% is going to be on the scale of 0 to 1, so it's 0.05. Right? I also want an annuity. Annuity, A, is equal to new annuity. That pays me, and I need to use a different account number here for identity, 54321, whatever. Again, I'm the owner, and it's going to be $500 a month for 10 years. There we go. I think that was what was in the annuity class, right? An account number, me, the owner, monthly payment, and number of years. Now, I do have a problem here that I've got me, right? I need to create myself. So person, P, or I'll call it me because that's what it represents, is a new person, and it's just going to be my first name and last name, I believe. Right? That's good enough. Right? What else was in the person class, though? We've got a first name, last name, date of birth. I'm not going to give that out. And we've got also a list of emails here. So we could go ahead and add all my emails if we wanted to, et cetera, et cetera. Right? But the thing is, both of these accounts own, through composition, the instance of this person called me. Right? You can have multiple objects that have ownership over one object, especially in Java, because you have automatic garbage collection. You don't have to worry about, well, okay, which one truly owns it, because one of you is going to have to clean it up, right? You don't have to worry about that because it's automated garbage collection. The only object-oriented programming language that you have to worry about stuff like that is C++, excuse me. Right? Okay, great. Let's go ahead and print these out to make sure that everything is working. System.out.println, S and A. There we go. Got to copy and paste a lot of code here. Copy and paste a lot of code, right? I want to cut that down now. Right? So we've got $100 and $500 per month for 10 years. First of all, I want to go into the classes and I want to identify some violations of the DRY principle. Remember, don't repeat yourself principle. We've got some repetition here. In fact, if I put these side by side, you'll see exactly what the repetition is. There's an annuity and there's a savings account. They both have an account number. They both have an owner. There's some repetition right there. Now, how are they unique? One has a monthly payment and term number of years. Over here, we've got a balance and an annual percentage rate. Right? Those are unique to each. That is a specialization. But these first two are a generalization. All accounts, savings accounts, annuity accounts, I don't know, checking accounts, stock accounts, whatever accounts you want to come up with, they're all going to have a number. They're all going to have an owner. So what I want to do is I want to make sure that I'm removing that redundancy by generalizing. Let's go ahead and create a new class called account. Right? Because what are both of these things? An annuity is an account. A savings account is an account. Right? Note there the key words, is a. Right? We started this discussion talking about animals, cats and dogs. A cat is an animal. A dog is an animal. This inheritance that we're setting up defines an is-a relationship. If you have a superclass and a subclass, the subclass is the superclass. Right? And if you can't, if you've got two things and there's some sort of a relationship and that does not hold, then you probably don't want inheritance. For example, a person, well, they live somewhere, right? So they have an address. Is a person an address? Nope. Is an address a person? Nope. That would be wrong inheritance if you took that kind of approach, right? But an account, a savings account, is an account. An annuity is an account. So how do we go about saying that? Well, we use the extends keyword, extends account. Right? So extends means that savings account is now a subclass of this class over here. Okay? We've got a savings account, which is an account. By the way, should I therefore have account in the name? Savings account is an account. Probably some redundancy there. So let's go ahead and change that by refactor, rename, and I'm just going to simply name it savings. Right? There we go. Saving account, nobody says that. Savings account. Okay? And by the way, everything else is fixed for me through the magic of my IDE. Right? It automatically changed every single instance of savings account to savings for me by going through and doing that. Okay? All right. Well, an annuity is also, it's not called, I didn't call it an annuity account. Right? I intentionally called savings account an account so that we could go through that exercise. I didn't do it with annuity because it was just too weird. An annuity account? No. Extends account. There we go. Now they're both in this hierarchy. In fact, I can show you that they're in this hierarchy by highlighting them. Annuity, where else are we? Savings account and account. There we go. Right. We have this superclass, subclass relationship here. Right. This is a UML diagram. This is what we want to eventually see in your design document. For this first draft, we were just looking for you to just sketch something out, take a picture of it, and put it in there so that we could actually give you some feedback on what it looks like. Some people went the extra mile and used an online tool. I don't know what they were using, but the one that I would use is app.diagrams.net. And you can start diagramming these things. And in fact, there's a whole list of things that you can do with UML over here so that it eventually looks like this. Right? That's if you want to sketch it out using a tool. Right? So again, app.diagrams.net. Otherwise, eventually what you're going to do is produce something like this. Just take your code and let it do all the work for you. Right? Now, the tool that I'm using here is Plant UML. When we post the notes, the full how-to is going to be posted. That's already on GitHub. Right? All you need to do is download something within Eclipse. It's just a plugin. All you have to do is highlight things, and then you can export as a PNG. Put that in your document. Great, you're done. Right? We were just looking for a sketch of something that looked like this. Okay? And also, by the way, on assignment 2, the first phase, we're not expecting inheritance. We're not grading on inheritance. You will definitely need inheritance on the second phase. So if you want to go ahead and do it right now and make your life easier, go ahead and do it. Right? Just do it correctly. Right? Extends account. Extends. All right, now we still have this this redundancy over here. Come on, over there. There we go. We still have this redundancy, an account number and an owner. What I'm going to do is I'm going to take those two things out of the subclasses and promote them up to the superclass so that they're shared between those two things. Let's go ahead and put it up here. There we go. And I'm going to go ahead and back to annuity and get rid of those. And get rid of those. There. Right? Now, you'll see here immediately that something happens. Right? For example, account number and owner. Do you see an account number and an owner anymore? Is it visible here at all? No, that's why it's not compiling. Where did I put it? I put it up here in the superclass. Right? And by the way, I'm going to have to go through the generate. Just to get this to compile, I'll go ahead and finish it off later on, but generate a constructor using fields, be done with that so that it actually compiles. Now let's go back over here to the annuity, for example. Right? There is no account number, there is no owner. How do I specify those? Two options. One option is to go back over here to the account and introduce a new keyword. Remember, things can be private or public. Right? Public, you probably don't want to do that. Why? Because now everything can see it, everything can do whatever they want with it, they can, they can muck with your data. That's bad encapsulation. That's breaking encapsulation because you are allowing people to just rip your object open and do whatever they want with it. Now, we did kind of protect it a little bit by using a final keyword, meaning that nobody can ever change that once it's been created. Right? By making it private, however, we've kind of closed it off a little bit too much. So is there a healthy medium between completely open and completely closed? And that introduces a new keyword here, protected. There we go. Protected and protected. Okay? Now, all my woes over here are gone. It now actually compiles. I now can see in the subclass, I can now see this, this owner account and this, or this owner and this account number. Right? What that does is it makes it visible not to the outside world, but to any subclasses that inherit from the superclass. That's one option. If you want to go with that option, great. That's your design decision. I'm going to go ahead and show you a different option. We're going to continue to make them private. We have this, this constructor here that takes an account number and an owner. Let's come back over here to annuity and see, ooh, cool. Right? Remember I said that that super keyword, ignore it for now? Now we're not going to ignore it anymore. So do you remember how we called a constructor, right, from another constructor? I think we did it in isotope. There we go. Right. To cut down on code, what we did is we had this constructor call that constructor up there by using the this keyword. So now infer. What does super refer to? The superclass, right? The superclass. So this is actually the constructor in the superclass, which is not compiling because it expects two arguments. Remember? Let's go back over here to the account. It expects one string and one person, the account number and then the owner. So I'm going to come back over here to annuity, and I'm not going to set my account number and my owner. Instead, I'm going to set my parent's account number and parent's owner by going account number and owner. There we go. And of course, you could have generated all this using the IDE if you wanted to. I like that solution a little bit better, but that's just me. That's my design decision, right? Because I like to locate things where they belong. So who's responsible for setting and handling the account number and the owner? The superclass, because that's why I created this hierarchy. That's why I created this, in this inheritance. So let it be up there, right? All right, great. Do the same thing over here for savings, right? That we're going to now change it so that we call this super constructor for both the account number and the owner, and then we don't have to worry about it anymore, right? Yes, I do have to set my balance and my annual percentage rate because I'm now a savings account. I have those two new things. I have that specialization. But the generalization, I'll go ahead and let my parent take care of that, okay? Now, there is still a problem here. These getters that I generated before, right? They can't see this account number, right? If I just say this dot account number, it doesn't know what you're talking about because they are private. Again, I could go back and make them protected, or I could do something else. I could get rid of these entirely, right? There we go, and get rid of this, and so it compiles. There we go. What's the problem though? When we printed this out over here in, let's go back to the console, what's one thing that I actually needed? I needed the account number to print it out. And it's not working down here at all, right? Okay, well, this account number, go back and make it protected and solve all my issues, or look for another solution. I do want the outside world, and in fact my subclasses, to have this functionality. You should be able to get this account number, right? You can't do anything with it other than print it out or look at it, but you should be able to get it, right? So what am I going to do? I'm going to go back to my account up here, and I'm going to create getters and setters, or not setters, just getters for this. Right? Now that solves my problem down here, as long as I'm calling that method, dot get account number, right? And get account number. Right? I can't access the variable itself, but I can access those public methods. Right? Get account number, get owner. Just as both subclasses both had an account number and owner, both subclasses had the getters and getters. Don't repeat yourself. Promote them up to the superclass. That's the generalization. Everything's great now, right? Now I can go ahead and generate my UML diagram by looking at it. Let's see, what does it look like now? Where's savings and annuity, right? And let's go back over here to plant UML and take a look at it, right? So much cleaner now. I don't have repetition here, I don't have repetition here. Instead, I took all of those things that were common to both of those classes and promoted them up here, right? Now, another benefit of doing this is, what if I have a new account type, a checking account? Do I need to start from scratch? No, I can inherit from this account up here. In fact, I could inherit from savings account if there's a very special type of savings account, right? Like they used to have like Christmas accounts. That were just a scam because they just paid you even less than a regular savings account. But I could inherit all the way down. I could inherit as deep as I want. Unfortunately, then you get into what's called the yo-yo problem, and we'll talk about that later. All right, great. What else do I want to do? Let's come back over here and to the demo, and I want to give myself some more money. So maybe I had 2 savings accounts, not 1, 2, 3, 4, but 5, 6, 7, 8. And that has $200 in it, but it's only like 1%. There's that Christmas account or whatever, right? And I have another annuity, not as good, not as generous, $100 maybe for 5 years or something, just to make it different. Okay, so S1, S2, A1, A2, change these to be S1, A1, cut, paste, go to 2. If you find yourself going like this, right, cut, paste, repeat, 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 you're probably doing something wrong, right? So let's think of a way that I can print them all out without having to cut, paste that print statement. What would you do? If I've got, say, 1 account, 2 accounts, 3 accounts, 4 accounts, when I've got 4 accounts, what would you do? A collection of some sort. Yeah. Yeah, let's go ahead and make a list. You jump to the conclusion too far, though. A list of savings accounts, my savings accounts, right, is equals to new array list. There we go. And I'll go ahead and add those, my savings account dot, add S1, my savings accounts dot add S2. Right? Now I need to repeat myself because I have annuities as well. Right? My annuity accounts. There we go. Add A1 and A2, A. Right. So if I did not understand inheritance too well, I would be forced to create 2 lists, one of savings accounts and one of annuities, right? And then I could iterate over those and be done with it. But the problem is I'd have to have, or now the checking accounts have been introduced. Should I have yet another list for checking accounts? No. Should I have yet another list for stocks? No, right? Let's rethink this. Right? Remember that a cat is an animal. A dog is an animal. So tell me about savings accounts and annuities. What are they? What are they both? Accounts. Let's go ahead and just create a list of accounts, right? Not call it my savings accounts, but just my accounts. What could I put into this list? Could I put in a string, hello, right? No. Why? Because is a string an account? No, it doesn't fall into that hierarchy that I built. Could I put in a number, 1, 2, 3, 4? or 1, 2, 3? No, because a number is not an account. But what is an account? S1 is an account. It's a savings account, which is an account, right? We follow this inheritance hierarchy. This is a relationship. MyAccounts.add S2. And guess what? I don't need this secondary list at all. All I have to do is say MyAccounts.add A1 and A2, so that I can iterate over all of them as if they were all some generic account. For account A in my accounts, system.out.println A. There we go. Run it. $100 for 5 years, $500 a month for 10 years. Right? I was able to treat them all the same because they were all the same from the perspective of this inheritance hierarchy. Okay? Two things that I want to fix, though, still. What's to prevent me from making an account? Account A is equal to new account. Right? X, Y, Z, 1, 2, 3. There we go. And I'm still the owner of that account. Right? What kind of account is that? Is it a savings account? Nope. No. Is it an annuity? Nope. It's no account. Yeah, it's no account. no account, right? No pun intended there, right? It's a no account, right? Well, it's something, right? I don't know what it is. Should I be able to do that, something like that? No. Probably not. Why? Because what in addition to like printing them out, oops, what's wrong with A? Oh, because I just created it up here. Some generic account. There we go. So that I can use A down here. So I also want to determine how much money do I actually have, right? In other words, I want to add up all the balances of all my checking accounts or savings accounts, excuse me. I want to add up the total value of my annuities, which is the number of years times 12 times the monthly amount, and that tells me how much my annuity is, right? $100 a month for 5 years, right? 5 years is going to be 12 months a year. That's going to be 60 months. So 60 times 100, that's 6,000, right? That's $6,000. Right? 120 times 500, that's 60,000. I don't know what that is, right? 5 times, well, yeah, $30,000, right? Because it's just 5 times as big as, no, I don't know. I don't want to do the math. That's why I'm writing this program, right? I want to know how much money I have. So let's go ahead and create a total. Initialize it to 0 because anytime you're summing something up, right, it's going to be 0 initially. And then what we'll do is we'll take that total and add on to it A's value. Right? Okay? So how do I do that? A dot. Well, I've got a bunch of stuff available to me. I've got the stuff that's built into the language, hash code equals, whatever, right? But I also have, where else is it? I have a toString method. I have get owner, right? I got get account number, right? Do I have a way of determining how much this account number is? Right? Like a savings account. What's the balance? Do I have get balance? Not yet. No. Right? Do I? Okay, well, a savings account has that getter, right? That's what I need. So what I'll do is I'll say, oh, could I force this account to become a savings account so that I can get its balance, right? So in other words, savings account SA is equal to savings account, or not savings account, but savings of A, right? So that I can say A.get balance, not at savings account, but just savings, right? Or not A, but anymore, but SA. There we go. Is that going to work? For the first 2 accounts, it will, right? $100, $200. I'll have $300. What happens when I get down here to the annuity account? Is the annuity account a savings account? No. So therefore, does it have a get balance method? No. Let's find out what happens here. Class cast exception. The annuity cannot be cast to a savings account because it's not a savings account, right? Can you force a dog to become a cat? No, that's an invariance, right? You can't do something like that. Can you make a cat become an animal? Yes, right? Because it is an animal. But can you necessarily take an animal and force it to become a cat? No, that's what we're doing here. We're taking an annuity account, which is an account, and then we're forcing it to become a savings account, which isn't going to work, right? If I only had savings accounts, then I could do it. So I could check for that. And I'm about to show you some syntax here just for completeness so that you know it exists. You do not want to use it. Right? This is wrong. If a instance of savings account, then it's safe to do this. There we go. So what I'm doing is I'm checking this account that I have in my hand right now. Is it a savings account? Yes, it is. Okay, then go ahead and treat it like a savings account and add it up. Else if A is an instance of annuity, then what can I do? Same thing, class cast it as an annuity. And now it's not get balance, what is it? Dot get monthly payment times SA dot get term in years times 12. Right? The amount of monthly payments times the number of years times 12 because there are 12 months in a year. Right? If I go down this road, what happens to all my code when I add a brand new type of account? A checking account. Else if. What happens if I add a stock account? Else if. Does this sound like the way to go? No. Because first of all, anytime I introduce something new, it breaks all my old code. Right? I have to add yet another, I have to add yet another else if statement, another case. Right? And second, it's just cluttered. Right? I'm breaking encapsulation here. This behavior belongs where? What is the value of this annuity? Right? That sounds like an annuity thing. Where does it belong? In the annuity class. What is the value of this savings account? It's whatever balance is in there. That sounds like a savings account thing. Where does it belong? In the savings account class. Right? So what I'm going to do is I'm going to come over here to the account, or not account, sorry. Let's start with annuity. And you know what? I don't like typing, so let's go ahead and come over here to demo and steal this stuff. Right? Actually, it's probably better to just retype it. I want another method. Public double get value. Right, there we go. And I'm going to return this dot, and I'm in the annuity class, so it's going to be monthly payment times 12 times this dot year terms. There we go. Times 12. Right? That's the value of an annuity. It's the monthly payment times the number of years times 12 for 12 months in a year. Right? What is the value of the savings account? Public double get value, and I'll return this dot. It's just the balance. Okay, that's what the value of a savings account is. Well, wait a second. You already have the get balance. Yeah, but if I don't have another common piece of functionality, I'm not going to be able to access it. Right? Again, over here in this demo class here, I had to force it to become a savings account in order to get the balance. Annuities don't have balances, but all of my assets have value, right? So let's go ahead and get rid of all of this. There we go. Print it out and change this back to A, and I'm going to go with dot get value. There we go. Still didn't work. Why? Again, let's go ahead and highlight these things. Here's my account, here's my annuity, and here's my savings account. Okay? I see a get value function. If you squint really hard, it's down here at the bottom. There's a get value function over there in annuity. There's a get value function over there in savings. But what do I have? I have a list of accounts. I also have redundancy, right? I've got a get value over here, get value over here. So where should this function belong? In the superclass. So let's do that. Except that when I put it into the superclass, does it necessarily have like a behavior? Public double get value. Right? Return what? Does this class have a balance? Nope. Does it have a monthly payment and a year's? Nope. Okay. So what could I return? I don't know. 0 for now. We're going to come back and change this behavior. Okay? That solved the problem over here, though. We have a common interface. every account is going to have a get value function. The savings account is going to do one thing. The annuity is going to do a different thing, specialization. But generalization up here, every account is going to have some sort of a value, right? I can now introduce loans. What's the value of a loan? It's a negative value, right? You owe $60,000 or something instead, right? But now I can actually treat them all the same and get how much am I worth right now total. What is this going to be? Right. I have $66,300. Cool. Right. It's all fake money though, of course, right? So that's really bothering me though, right? You shouldn't have to return this flag value here. Maybe you would change this to a big D double and then return null as a signal that it's not, the value is not 0, the value is I don't know, right? I'm not even going to set this, right? But there's a even better way of doing that. Let me undo, right? I'm going to do what's called an abstract class. And this is what you're going to do partially in your lab on Wednesday. I'm going to make this into an abstract class. What is an abstraction? An abstraction is a generalization of an idea. Again, what is the here we go. Ignore this down here for now. Just look at the animal, dog, and cat relationship here, okay? Yeah, look at the animal, dog, and cat relationship here, right? So can you actually hold an animal in your hand? Like just a generic animal? What does it look like? Does it have feathers or fur, right? If you were to hold a dog in your hand, right, that's concrete. That's an idea. That's a concrete idea. There is a dog in my hand. It has black fur, and it's licking me, right? It's doing stuff. What about a cat? You can hold a white cat in your hand, right, and it's purring, all right, whatever, right? That is a concrete idea. But the abstract idea of an animal, can you hold that in your hand? No. So you should not be able to create concrete versions of abstract ideas. By making this into an abstract class and saving it, let's come over here to the demo. All right, there we go. What happens now? Some generic account. Can you create a generic account, a generic abstract account anymore? Nope. So that solved one problem. And it also solves my other problem of, well, what should I do here? The answer is, don't do anything. Do not provide an implementation of this function. Instead, make the actual function or method abstract as well. Right? That abstraction says, you don't have to say what goes on with this getValue function. That's for the subclasses to do. Right? That's their responsibility. My responsibility up here is just to simply say that every account has a value. In other words, it has this method called getValue, and it returns a double. So that you can do stuff like this. Put it into one list, iterate over it, and get your total value of your portfolio or whatever. Right? That's the solution that you probably want. Right? You don't want people to be creating generic, abstract accounts. You don't want to be forced to specify how these things work when you don't know how they work. Just make it abstract. Now down here in the savings account, it would be wrong to not specify how getValue works. If I save this, it's going to start complaining. Savings. The type savings must implement the inherited abstract method getValue. Right? Why? Because it's not an abstract class. Right? So let's undo that and fix it so that we are providing behavior. You see this all over the place. Let me go ahead and show you, let's see, this? Yeah. Here's a simplified version of it. Everything that hopefully you're well familiar now with the types of collections that you've got in Java. You've got sets, which are unordered, unique elements. You've got lists, which are ordered and non-unique elements. You can put 10, 42, 42, 42, 42 into a list all you want. We've got this, under the hood though, we've got this entire inheritance. A set and a list, they're both collections. Right? A collection is just a generic idea of a box that you can put stuff in. A set provides a specific behavior. I will hold stuff, whatever you want to put into this set, but I'm unordered and I do not allow duplicates. Over here, a list provides a different specification or different specializations. I am a list, so I hold things in an ordered manner so that you can sort me. You can't sort a list. You can sort me, and also I do allow you to have duplicates. Right? Now that's still way too general and generic. The ones that I've shown you are hash set and array list, but there are other types. For example, in a list, this is something that we'll get to after the break, after the spring break, you have, I've been using an array list. What do you think that is? It's a list that holds stuff in an ordered manner, allowing duplicates using, what do you think? On array. I can't highlight it very well. An array. What about this one over here, a linked list? That's a different type of data structure. Instead of using an array to hold stuff, it has what are called nodes. This is the first node. It holds one thing. That points then to the next node, and it holds another thing, which points to another node, and that holds another thing, right? So it's basically a chain, and you can add links at the end of the chain or at the beginning of the chain, right? And there are various properties that are associated with a linked list. A hash set is one that uses a hash table. We won't get into that in this course. A tree set is a set that uses a tree. We will get into that in this course. What is a tree? Well, you're looking at one right now. Right? You've got this root down up at the top, computer science. All of our trees grow downward. It's not a real tree. So you've got this thing up here, there's the root, and then it branches out, and you've got the leaves at the bottom. That's a tree. Right? And in fact, this is a binary tree. All right. Another example, an extended example. That is just a simplified version of it that I wanted to show you. Here's the actual, oops, not this one. Here's the actual hierarchy, and I don't think that this is everything either. Right? There we go. So we've got this multi-level of abstraction. Down here you have actual classes that you use, the tree set, the hash set, the array list, the linked list. Within, above that, we've got this hierarchy of abstract classes. I just showed you basically this collection right here, which is the most abstract all the way up here, but there's a whole bunch of things in between because I'll provide just a little bit more specialization. I'll provide more specialization until you get down to the last part, and this is well defined now. Why? Because I want all lists to inherit the behavior in this abstract list here. I want all sets and lists to inherit this abstract collection behavior, right? So it's a way of organizing your code so that you don't have to repeat yourself. If something is common to both this and this, send it up. If it's common to this and this over here, send it up further. Keep sending it up until you have this pure abstraction up here, which is called an interface. An interface doesn't define anything. Only signatures of functions, right? And all of these are like iterable, collection, set, list, right? Serializable, dec, or queue. We'll get into those later. In fact, some of them don't even define functions at all. They just define aspects. For example, random access. We all know what random access is. If not, here's an array, right? It has 5 elements. I can, for free, jump to the third element. Why? Because it's all contiguous in memory. If your memory starts here, and you know that you want to go to the third one, it's just a memory offset. Okay, I need to go 1, 2, 3, 4, 1, 2, 3, 4, 8 bytes jump in memory to over here. That's what random access is. Random access is an array list because it uses an array, but not a linked list, and certainly not any sets because they're not memory-based like this. There's nothing in random access that defines a function or a method. It's just saying that it's okay to make sure that you can jump a memory location within this class, but not that class or any of the other classes. Right? Up here, now we've got abstract. We've seen classes. We started out with classes. We've seen an abstract class. Our first instance here is the account class, right? And now we've got yet another idea of abstraction in Java called an interface. That is a pure abstraction. An interface is just an abstract class with all abstract methods. Right? Here's an example. This is sort of like what you're going to see in your lab this week. Right? I've got an employee. I've got 2 different types of employees. I've got an hourly employee and a salaried employee. Right? But I also have interns and suppliers. Right? Now, in my business model here, I have to pay employees. Right? And I also have to pay the suppliers, or they don't supply anything, right? So that idea is kind of payable. I have to pay them something. How much do I owe them? I owe the employee a certain amount. Well, how much do you owe them? I owe them the number of hours that they worked that week times their hourly rate. That's very specific behavior. What about salaried employees? Oh, well, they get paid an annual salary, so if 52 weeks a year, divide that by 2 pay periods, 26, whatever their annual salary is, divided by 26, that's how much I pay them, because they are payable. Unfortunately, in this company, we have unpaid interns, right? We do not pay them, right? So they don't implement this interface up here. However, what is an intern? Right? We're not treating them like it because we're not paying them, but an intern is a person. Right? An employee is a person, but is a supplier a person? Nope. What are they? A company, an entity, whatever, right? You define that depending on your business rules. Right? These are pure abstractions up here. These are potentially either concrete classes or abstract classes. But by defining interfaces, what you can do is you can free yourself of this entire hierarchy. You can say that there's this concept of this person here. They have a first name and a last name. Well, an intern is a person, so therefore they would have a get first name, get last name function. An employee has a get first name, get last name function, but a supplier would not. Payable. An employer has a amount owed, right, function. A supplier has an amount owed function, but an intern doesn't because, again, we're not paying them. Now, that's just for illustrative purposes, never, especially in computer science. Never take an unpaid internship. Even 10 years ago, I think that certain companies, even in Lincoln, are going to be paying $20 an hour. I don't know, does anybody want to offer up, I don't want to call anybody out, but does anybody want to offer up their hourly wage for internships right now? Humble brag or anything? No? Okay. All right, may or may not have an internship. Certainly you should have one as early as possible, even in your first summer, right? Everybody in here is probably more than qualified for many of the internships out there already, right? So that is an inheritance hierarchy. What could we do over here with our accounts? Right? What we could do is we could create an interface, and to do that, you just go new. Instead of a new class, you create a new interface. Right? And what I'm going to do is I'm going to call this ownable. Right? There we go. So that this thing, anything that implements this interface, is going to be required to have a person get owner. There we go. It's pure abstraction. Do you see any methods in here at all? With a definition, I should say. No, because it's pure, right? It's a pure abstract class, right? It is so abstract, it does not even have variables, right? It's so abstract, it doesn't even have any methods at all, right? Other than the interface here. Now what I can do is I can go down here to annuity, and I can say extends account, implements, what is it, ownable? There we go. And we're already good on that because I've got that I inherit that get owner method from its superclass. So that tells me, well, wait a second. A savings account is ownable. So I'd have to repeat myself here. Implements ownable. Implements ownable, right? I've got that in savings account now, and I've also got that in annuity. Sound right? Maybe, maybe not, right? It's ownable if it's an account. So what if I put that up here in the superclass? Now all accounts are ownable, right? And I don't have to repeat myself. But now what if I introduce a brand new type of account that doesn't have an owner, right? Maybe like a, I don't know, new class, business saving, business or petty cash. I don't know. There we go. So what is petty cash? Petty cash is an account that I've got incidentals, right? We need to reimburse somebody because they went to Walmart and bought a bunch of cleaner, right? Because we were out or something. Instead of our usual supplier, we just have a petty cash account. Nobody owns that. Maybe it's owned by a company, not a person. Right? Now, if this extends account, my choice here has forced me to do something that doesn't fit with my business model, that doesn't fit in my hierarchy, right? I have to add a constructor. After I've added a constructor, I have to have a person that is an owner. If I don't have that, how can I get the owner? So if I want an account without an owner, then probably don't want to do something like this, right? Implements ownable. Just like over here, if I want it to have an employee that I don't pay, they're called an intern, then I probably shouldn't make all employees payable, or I shouldn't put intern here down under this hierarchy. Right? So this is why design is so important, because if you have the wrong hierarchy up front, right, then you're locked in, right? And now your code is like 5 years old. Oh, we've got a brand new idea of this unpaid intern, right? 5 years later, how do we fit this into our hierarchy without breaking it? You don't, right? Whereas if you design it up front and say, okay, well, not everybody is going to be a person, right? We've got a supplier that we have to pay, and so we need to make that into an interface. We need to make that a little bit more abstract, right? Then you move things around on your whiteboard, and okay, well, that makes sense, that makes sense, that makes sense. Anytime you find yourself locking yourself into this hierarchy, right, think, is that absolutely the relationship? An hourly employee is an employee. A salaried employee is an employee, but not all employees are payable. We've got this intern over here. They're an employee kind of, but they're not payable. All right, well, there's your argument for redesigning it to make this pure abstraction above it. Right? Imagine if Java had done that. And by the way, they did. Imagine if Java had locked everything in, that they should ever want to do into a hierarchy like this, that, oh, now we have something new. For example, what do you not see on here? A map, right? Where does it go? Well, it's a collection. Why isn't it in there? Because if it were a collection, it would be forced to act like all other collections, and it's not. A collection holds stuff. What does a map do? It maps stuff from a key to a value. That's why they didn't lock it into this hierarchy. Had they locked it into this hierarchy, they would have had to do things that didn't make any sense for a map. Or they would have to do things for a set and a list that didn't make sense for a set and a list, but they made sense for a map. Right? Locking yourself into a hierarchy is very, very risky. Right? That's why inheritance is good, but it's only good up to a point. On Wednesday, we're going to look at the consequences of bad inheritance with anti-patterns. Okay? All right, see you then.